Here's the fourth theorem to be introduced in this series of lessons, and that theorem states if angles are supplementary to the same angle, then they are congruent. And in order to prove this theorem, we're going to review a couple of things that you've probably seen previously in an algebra course. And the first one is the substitution principle. Quantities that have the same value are interchangeable. And the second is the subtraction property of equality. If two quantities are equal, then if the same quantity is subtracted from each of the original quantities, the differences are equal. Or in other words, for real numbers a, b, and c, if a is equal to b, then a take away c is equal to b take away c. And now let's set up a two-column proof for Theorem 4. It states that angles are supplementary to the same angle. So that's the given. We now have an angle 1, which is given as being supplementary to angle number 3. And there's also an angle 2, also supplementary to angle 3. And our job is to prove that angle 1 is congruent to angle 2. And by the way, this is one of many proofs that essentially state the obvious. But we're going to prove it even though you might look at it and say, well, it's obvious. Well, the first thing we're going to do is write the first given, that angle 1 is supplementary to angle 3. And then we're going to point out that then the measure of angle 1 plus the measure of angle 3 is equal to 180 because that's the definition of supplementary angles. Then we'll state the second given. Angle 2 is supplementary to angle 3. Then we'll state that the measures of angle 2 and angle 3 have a sum of 180, again, the definition of supplementary angles. And now we're going to use the substitution principle. In line 2, we have the measure of angle 1 plus the measure of angle 3 is equal to 180 degrees. So we're going to replace the 180 that sits there in line 4 with the expression the measure of angle 1 plus the measure of angle 3. And then we'll write that down in line 5. So now we have that the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle 1 plus the measure of angle 3. And that leads us to the subtraction property of equality. We have an equation in line 5. Each side of the equation contains the measure of angle 3. We get to subtract the measure of angle 3 from both sides, leaving us with the measure of angle 2 is equal to the measure of angle 1. And then we know that if the measures of two angles are equal, those two angles are congruent. And Theorem 5 is similar to Theorem 4, but a little bit different. It states, if angles are supplementary to congruent angles, then they are congruent. So we set up the two-column proof again, and now we have that angle 1 is supplementary to angle 3, and angle 2 is supplementary to angle 4. So instead of angle 1 and angle 2 being supplementary to the same angle, they're supplementary to different angles. But those two different angles are congruent to each other. The third line in the given is angle 3 is congruent to angle 4. Our job then, and again it's kind of obvious, but we're going to prove that angle 1 is congruent to angle 2. And it's similar to the previous proof. We state the first given, which the reason for that is it's given. Then we point out that their measures add up to 180 because that's the definition of supplementary angles. Angle 2 is supplementary to angle 4, that's given. And so in line 4, the sum of the measures of those two angles is 180. Then in line 5, we state the third given. Angle 3 is congruent to angle 4. And if angle 3 and 4 are congruent, of course their measures are equal because of the definition of congruent angles. And now we're ready for a couple of substitutions. Since the measure of angle 3 is equal to the measure of angle 4, we'll go back to line 4 and substitute the measure of angle 3 for the measure of angle 4. And then we'll write that new equation with the substitution in it down in line 7. So now we have the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. And then we substitute again, much like we did in the first proof. Since the measure of angle 1 plus the measure of angle 3 is 180, we can substitute that in for the 180 that appeared in line 7. And now in line 8, we have that the measure of angles 2 and 3 is equal to the measures of angles 1 plus angle 3. So we've used substitution in 2 consecutive steps. And now we're going to subtract the measure of angle 3 from both sides, which, just like it was in the last proof, is a subtraction property of equality. giving us that the measure of angle 2 is equal to the measure of angle 1, and therefore the two angles are congruent by the definition of congruent angles. Theorem 6, if angles are complementary to the same angle, then they are congruent. The proof is very similar to the proof for Theorem 4, so you can try it if you want, but we're not going to show it again here. And the same, Theorem 7, if angles are complementary to congruent angles, they are congruent, and that proof is very similar to the proof for Theorem 5. So we're not going to show that here. In this lesson, we looked at 4 theorems. If angles are supplementary to the same angle, then they are congruent. If angles are supplementary to congruent angles, they are congruent. If angles are complementary to the same angle, they are congruent. And if angles are complementary to congruent angles, they are congruent.